So this video, we're going to work out the solution to activity 3.1, and we're actually given g prime of x as opposed to g of x and then finding the derivative. So we're going to go straight from there, and part A regards finding our critical points. Remember that those are any inputs that make our derivative 0 or undefined. So looking in the numerator, we've got critical points at -4 and 1. And then we have to worry about the denominator too, because 2 is a point where our derivative is undefined. So all of these are critical values. Now, we're going to make our number line to determine what's going on with our original function. So, -4, 1, and 2. And what we're going to do is we're going to test a point in each interval to figure out whether or not our derivative is positive or negative. And sorry, not f, g prime. So first off, let's try -5. Now all I care about is whether it's positive or negative. So if I put -5 in here, I get negative, because this negative number be getting squared to be positive, over a negative. So negative divided by a negative is positive. That tells me my original function g is increasing on that interval. So I like to write what g is doing underneath. In between -4 and 1, a very easy critical point is 0. 0, positive. 0 because of the square, positive. And 0 down here, negative. So that's negative. That means the original function would be decreasing. Okay. How about, now in between here, 1.5 is about the best I'm going to do, but again, all I care is if it's positive or negative. So putting in 1.5, positive, positive, negative. So that's going to lead me to a negative because I got a positive over a negative. Finally, test value of 3, positive, positive, positive. So that's positive. So decreasing, increasing. So I can list those intervals. So first off, we have a local max at -4 because it went from increasing to decreasing. And we have a local min at x equals 2. Now at 1, we do have a place where the derivative is 0, but it's decreasing and decreasing, so it will have a horizontal tangent, so as we look at one of those graphs that flattens out but then continues on. Finally, does g have a global max or a global min? Well, notice what's going on at the ends. This graph comes in as increasing. So if we were to sketch a rough sketch based on our derivative, it's going to come in increasing until we get -4. Then it's going to decrease. We're going to have that horizontal tangent, and it's going to decrease again. Then at 2, it's going to go back to increasing. Again, a rough sketch. But what this tells me is it's going down to -infinity, and it's going up to positive infinity. So there would be no global max or min. We would have wanted to see both ends going the same direction to be able to say that we'd have max or min. If they were both up, we'd have a global min. If they were both down, we'd have a global max. So that's how we can tell by just looking at the derivative whether or not we'll have one. We would not be able to find out what they actually are without knowing the original function.